Suppose a certain amoeba population quadruples every week. Now, quadruple means it multiplies by 4 every week, right? Okay. Now, could you guys make sure you're on mute? Okay. So now, if you start with one amoeba, then the population y grows according to the relationship y is equal to 4 to the x power. In other words, this is a typical exponential growth equation. The graph of this relationship appears below, and we have this nice little graph plus some amoebas. But wait a second. A week is made up of 7 days, right? So it's not just one day. We can have a fraction of a week, right? So what happens if we want to use our equation so that we can find out how many amoebas there will be after half a week? So in other words, instead of 1 week, we're going to have 1/2 as the week in our exponent. So right now I want you to take about 15 seconds and I want you to find on the graph how many amoebas will we have after 1/2 of a week. All right, how many amoebas? How many amoebas? Show me with your fingers. All right, everyone is showing me 2 amoebas, and I'm assuming that we looked right here at half a week. We went up the graph. That's 2. All right, that makes sense, right? So in other words, something happened where we had 4 to the 1/2 power, and that would equal 2. Well, wait a second. What mathematical property or operation did we use to turn 4 into 2? In other words, what do you do with 4 that would get me 2? Are there any ideas what we could do with 4 that would get us 2? Nolan?
Divided by 2?
I could divide it by 2. Can we agree that 4 divided by 2 is 2? Mm-hmm. Okay. All right, do I have another volunteer that can give me another thing that I can do? Owen, that was a really cool, I enjoyed watching you guys do tricks on your bike ramp yesterday. It was cool. All right, so what else can I do with the 4?
You can multiply by 1/2.
I could multiply it by 1/2. Okay, what else could I do? Nolan? I could subtract 2. What else could I do? Macy?
Add -2.
I could add -2. Is there anything else that we could do with 4 that would equal 2? Is there another thing that we could do? I think there's one more. Do you want to take a guess?
Divide by something?
Oh, well, we are already dividing by 2.
I know, but...
And so 4 divided by 2 is 2, and there's nothing else that we could divide by. Any take it? So I think...
Well, Lily.
Lily?
Oh, never mind.
Never mind.
Macy?
I think there's...
To the 0.5 power?
Well, yes, all right. That is very, very good, because we know that taking 4 to the 1/2 power equaled 2. But I could swear that there's something that looks like a division symbol, maybe, that might help out. Max?
4 to the 1/2 power?
Yes, 4 to the 1/2 power did get us 2, using our graph here. But can anyone think of I think there's a symbol that looks a lot like a division symbol.
The 2.
No idea? Not a fraction. Does this ring a bell?
Square root.
Is the square root of 4 2?
Yeah.
Okay. So when we're taking a base to a fractional exponent, in this case 1/2, we are doing one of these things to get to 2. Any guesses which one we're going to be doing?
Owen.
Owen?
Square root.
This is definitely going to be talking about square roots. So 4 to the 1/2 power is the same thing as saying 4. What is the square root of 4? So that's what's happening here. We're taking the square root of 4. And so here we go. Look, we have a whole bunch of text. Oh, look, square roots. Great. Now, the rules of exponents will still apply for fractions. So the rules that we learned before will still apply even if we have a fraction. And then, what about this? What is the cube root of 8? What's another way of saying?
2.
Okay, the cube root of 8 is 2, because 2 times 2 times 2 is 8. If I were to turn this into an exponent, well, if 1/2 was taking the square root, what would be the cube root as a fraction? 1/3. And yeah, it's right here too. So yeah. Now we can apply this to just about any root if we have the nth root. In other words, if we have a base to the 1/n power, that would just be equal to the nth root of a. And so this will apply for all fractional exponents. But don't worry, this is just an introduction into fractional exponents, so the numbers will be very, very easy to work with, I promise. Are there questions so far? No. All right. All right, do the rules of exponents apply? The answer is yes. All right, so here's what we've got for today. What does 16 to the 3/2 power mean? So we have 3 students. We have Marie, Littrell, and Jacala, and they applied some rules of exponents, and you are being asked to tell us if they applied those rules correctly. Then you're going to pick the rule that is correct, or the method that is correct, that makes the most sense to you. And you're going to use that rule to simplify these 2 problems. Then, for question B1, you will use the rule of exponents to make these problems much easier to work with. Are there questions about what I'm asking you to do so far?
Nope.
All right, so in that case, I would like you to use your common rooms. We have all 8 working today. So boys go to the normal common rooms, girls go to the common room 2. I expect everyone to come back in 10 minutes. So I want you to do A and B in the next 10 minutes.
They've already halfway.
Yes, what's up?